All right, so now we're doing chapter 4.4. And yesterday we were just talking about the unit circle. So remember when we were in the unit circle and the radius was 1, we said that the sine of theta is equal to the y coordinate um, at any angle around the unit circle. And cosine of theta was equal to the x coordinate. And tangent of theta was equal to y over x. And the reason that was true was because r was 1. So really we were saying like sine of theta equals y over 1 and cosine of theta equals x over 1. And that was not, 1 was not involved for tangent. So we can generalize this rule for a circle with a radius of any length. It doesn't have to be the unit circle. R could be 2 or 3 or whatever. So a lot of our AP questions are going to use a radius other than 1. So we just have to look at how to adjust the formula to make it more general instead of just unit circle. So for any angle in a circle that's centered at 0, 0, the angle is the central angle. You've got some sort of horizontal distance x and vertical distance y to get you to a point on the circle, xy. And the radius doesn't have to be 1. It can be anything. So let's just call it r and see where that takes us. So the sine of theta, I'm still kind of in SOHCAHTOA mode from last section. Sine of theta was opposite over hypotenuse, so it would be y divided by r. Just like in the unit circle, it was y divided by 1. We just kind of dropped the divided by 1 piece after a while. Here, if r is 2, I take the y coordinate, I divide it by 2. Cosine is adjacent over hypotenuse, so it's x over r. Tangent is still opposite over adjacent, so it's still y over x, so it's unaffected by whatever r is. The reciprocal functions are still just reciprocals, so cosecant will be r over y, secant will be r over x, cotangent will be x over y. And so what we're often interested in doing on this AP test is figuring out, well, what are the coordinates of x and y if they give you an angle and they give you a value of r? So it's useful to rearrange the sine and the cosine formulas and solve them for x and y so that we have a quick formula for how to figure this out. So if I just multiply r to the other side, I get x is equal to r times cosine theta. And similarly, if I do that with the sine formula, if I multiply r to the other side, I get that y is equal to r sine theta. And so this gives me a formula for finding ordered pairs. If I want to know what the xy coordinate is, if I want to know what the xy coordinate is at any angle, excuse me, with any r around the circle, it's r cosine theta for the x coordinate, r sine theta for the y coordinate. So we can use that for this first problem. I tried to model a couple of our examples based off of what I saw in AP Classroom. So for this one, they always like to kind of complicate things with words, right? So let's draw what we're given. A circle has a center at the origin with a radius of 5 units. So let's just start there. You don't have to label the 5 yet, but just draw a circle whose center is at the origin. It's not going to be perfect. That's fine. In the xy plane, an angle in standard position measures 7 pi over 6. Remember, that just means we have this angle whose initial side is on the x-axis. 7 pi over 6 is one of our common angles. You need to know that it's down in quadrant 3. So this is 7 pi over 6. And we normally label it on our sort of outer edge of our circle, but remember what that means. Excuse me, what that means is that this angle all the way around is 7 pi over 6. This is theta. All right, find the coordinates where the terminal ray intersects the circle. That is just a fancy way of saying find the xy coordinates of this point right here. The point on the circle is what I've been saying. We just came up with a formula, right? We said any xy should be equal to r cosine theta, r sine theta. Well, they gave us r, right? The radius is 5 units. That's this length right here from center to circle. So that's 5. So 5 times cosine of theta, which is 7 pi over 6, and 5 times sine of 7 pi over 6. This is why the unit circle is important. We had problems like this probably on last night's homework. How do we figure out cosine of 7 pi over 6 and sine of 7 pi over 6. Now, you don't need to draw the entire unit circle, but you do need a little piece of it. 7 pi over 6, let's just memorize what the coordinate is at pi over 6. So if you don't have these first three coordinates memorized, that is definitely something to study before our first speed quiz. So the first coordinate at pi over 6 is radical 3 over 2 for x and 1/2 for y. And the reason that's important is because if I know that one, I know all of the other pi over 6 coordinates. Remember when we built the unit circle, we reflected this into each quadrant. So I want to know about 7 pi over 6. Well, 7 pi over 6 is negative radical 3 over 2, negative 1/2. Now this is the unit circle, so remember we need to take these values and multiply them by 5. So now I have that 5 cosine of 7 pi over 6 is 5 times negative radical 3 over 2. And 5 times sine of 7 pi over 6 is 5 times negative 1/2. And my last step is just to clean this up a little bit. So the xy coordinate, where the terminal side intersects the circle, is negative 5 radical 3 over 2, negative 5 over 2. All right, this problem is just a kind of a classic trig problem. We have a lot of these in the textbook. Let negative 3, 4 be a point on the terminal ray of theta in standard position. Find sine, cosine, and tangent of theta. First thing is just plot that point correctly. So in an xy plane, we go left 3, up 4. There's negative 3, 4. When we say that's a point on the terminal side of theta in standard position, we always connect that ray back to the origin. And they're saying that theta is this angle here, some obtuse angle. I don't know what it is. Now, to figure out what angle it is, we need to figure out, or not to figure out what angle it is, sorry, to find sine, cosine, and tangent, we need the value of r. We have x and y. We're just missing r. Now, remember, this does form like a little right triangle. We have x and we have y. So x squared plus y squared is equal to r squared. So that means that, now this is a triple, but it means that I should be able to do 3 squared plus 4 squared equal to r squared and figure out what r is. So now r comes out to 5 because it's a Pythagorean triple. R is always positive as well. So when you're doing the math on this, even if you're down in quadrant 3 where you kind of think maybe r is negative, it's not. The hypotenuse, r is a distance, it's always positive. Okay, so with that said, find the sine of theta. Well, sine of theta is y over r. And now I have both of those values. Y is 4 and r is 5. And find the cosine of theta. X over r is negative 3 over 5. And tangent of theta is y over x, and that is 4 over negative 3, or you could say negative 4/3. All right, on to the next problem. This is also styled after something I found in AP Classroom. We have practice on each of these problems in our homework tonight. Find the distance between points A and B. So find this vertical distance. If angle COB is 13 pi over 15, so that's our theta, and the radius of the circle is 8. All right. Now, one thing that's not marked off in my picture, I probably just forgot to mark this in, but these A and B they look like it, but they are equal distance from each other. So whatever this distance is here is equal to this distance. So if I can just find this vertical distance up to B, I can double it and find the length of A to B. And the good news is we have enough information to find that vertical distance. B is some sort of coordinate on the unit circle that's sitting at xy. And y is the vertical distance, right? You go left x and up y to get there. And we know that y is equal to r times sine theta. So the more comfortable you get with writing r, x and y as r cosine r sine theta, the easier these problems get. Because now I just have to say, well, the radius they gave me was 8. I've got the sine of 13 pi over 15. And I need to use a calculator if I want to get a decimal approximation for this, because 13 pi over 15 is not a common angle. So that's not one that we have memorized. All right, so 8. Oh, also, make sure your calculator's in radian mode. So it's probably in degree mode from what we just did. Or if you're in physics, it might be in degree mode. So press mode. Make sure radians is highlighted. I don't know why I switched it to degrees. And then type in 8 sine of 13 pi over 15. So you know what mode to put it in because whatever angle you're in radians, so whatever angle you have is your final answer. All right, sorry about that, slight interruption. Okay, so I get 3.254. There's no label on the radius, so there's no label on this. Now remember, the distance from A to B is not equal to y, it's equal to 2 times y. So keep that decimal on your screen, multiply by 2. 6.508 is the distance between A and B. All right, last idea for today. It's helpful to know and have memorized which trig functions are positive and which are negative, depending on which quadrant you're in. So we have a mnemonic device to help us remember that. All students take calculus. This helps you remember that all of the trig functions are positive in quadrant 1 because all of the x and y coordinates are positive there, right? You have x, y. And then students is for S to remind us that sine is the only positive value in quadrant 2. That's because all of the x's are negative, but the y's are positive in quadrant 2. Take is T for tangent. Only tangent is positive in quadrant 3. That's because both x and y are negative, so when you divide them to get tangent, you get a positive. And calculus, C, calculus is for cosine. So all students take calculus. So this final one, cosine is positive because all the x's are positive, but the y's are negative in quadrant 4. So all students take calculus will help you with a problem like this. In number 4, I'm not given an ordered pair. So if I'm not given a point, I don't immediately know which quadrant I'm in, but I'm given information about positive and negative signs. Given that sine is negative 2/3, so sine is negative, and tangent is greater than 0, so tangent is positive. Right there, you can tell which quadrant you're in. So take a look at your charts. Tangent's positive, but sine is negative, and that only happens in quadrant 3. So now we know which quadrant we're in. We know that sine and cosine should be negative, tangent should give me positive answers, and the reciprocals will follow along. Find the remaining 5 trig functions. Okay, now what about the 2/3 part? So sine is equal to 2/3. Remember, sine theta is equal to y over r. So if that's equal to negative 2/3, it means that y is equal to negative 2 because r is always positive. So r is positive 3. And we can use Pythagorean theorem to figure out what that missing piece is. The reason we keep using Pythagorean theorem is, remember, this is also the equation of a circle. So either way, we're talking about points that are on a circle. All right, so x squared plus 4 equals 9. X squared equals 5. Now, x technically equals plus or minus radical 5, and which one is it? Remember, you're in quadrant 3, so x should be negative because we're in quadrant 3. So now I just need to find the rest of the trig functions. They gave me sine. Cosine theta is x over r. So x is negative radical 5, excuse me, over 3. Tangent is y over x. The negatives will divide out to positive, as they should. We should be positive in quadrant 3. And we're going to rationalize 2 radical 5 over 5. Cosecant theta is the reciprocal of sine. So I didn't need any of this to find cosecant theta. Secant theta is the reciprocal of cosine, negative 3 over radical 5, which you need to rationalize, negative 3 radical 5 over 5. And finally, cotangent theta. Remember, take the reciprocal of your non-rationalized function so that it's much easier. You just get radical 5 over 2, positive because the negatives divide out, and that's the final answer. All right, last type of problem for today. So again, you're given a trig function and some sort of other information, and we're supposed to find the 5 remaining trig functions. Now cosine of theta is equal to 0, so an x-coordinate has to be 0, and theta is somewhere between 0 and pi. So sketch that real quick. What does that mean? Theta is between 0 and pi, means theta is one of the angles in the top half of the circle. And we're thinking, okay, where are the x-coordinate, which one of these angles has an x-coordinate of 0? X-coordinate of 0 means you don't move right or left. You've got to be at the top of the circle, which does have 0, 1 as its coordinate. There's no mention of a radius, and we can go back to using the unit circle here because it doesn't matter what the radius is. I can say 0, 5 with a radius of 5 or 0, 10 with a radius of 10. So I'm just going to go 0, 1, radius is 1. If you're at any of these non-quadrant angles, the radius is irrelevant because you're just using x or y or x over y or whatever. All right, so we have cosine. So we're going to start with sine theta is equal to the y coordinate, 1. We have cosine. Tangent theta is y over x, 1 over 0, which is undefined. Cosecant theta, the reciprocal of 1 is 1. Secant theta, the reciprocal of 0, remember, it's like 1 over x if that helps you. You get 1 over 0, which is undefined. So you could also just remember that the reciprocal of 0 is undefined. And then the flip side of that, the reciprocal of undefined will be 0 over 1. So that's 0. All right, we're going to stop there for today. Please come to office hours if you have any questions.